Hello. Today I'd like to give a short review of this. The SvBony SV231 color correction filter. Its function is primarily to decrease the chromatic aberration you get whenever you're using a refractor telescope. Chromatic aberration, kind of a fancy word for color error, means that the light coming in through the lens in the front of a refractor hasn't had time to focus. So you have unfocused light, which commonly gives you a blue or purple halo or circle around the object you're looking at. Bright objects like a foolish moon or the planets Jupiter or Venus will produce significant chromatic aberration. There are several ways to address that. One is to do something like this. Make your telescope long and skinny. And that's because the longer the focal length, the more time the light has had to come to focus. This particular scope here has a 900 millimeter focal length. The other thing you can do is to reduce the aperture, the size of the lens. This has a 70 millimeter lens. If you take the focal length, 900, divided by the aperture, 70, you come out with about 12.85, which means this doesn't have a whole lot of chromatic aberration. Once you get to a focal ratio of about 15, all the light has had time to focus, and you don't get chromatic aberration. Another way to reduce chromatic aberration is to take the cap off the plug out of the dust cover. A lot of refractors have a little hole in the dust cap. If you take that, and there's a plug in it, if you take the plug out, this 80 millimeter refractor becomes a 45 millimeter refractor because most of the light out here is being blocked. The center part of the lens has the least curvature and therefore the least chromatic aberration. Plus, in reducing the size of the lens, this becomes instead of it being a 80 millimeter 400 focal length f5, it becomes a 45 millimeter focal, 45 millimeter 400, which gives it about an 8.5 focal ratio. So that gets rid of a lot of chromatic aberration. Another way you do it is by adding more lenses. This is a doublet. Almost all modern telescopes are doublet. You have an objective lens, which is convex and made of crown glass. And then behind it, you have a second lens, which is concave and made of flint glass. The flint glass helps to correct the chromatic aberration. There are a lot of telescopes that use a different kind of glass other than flint glass. They'll use something called extra dispersion glass, like FPL51 or FPL53. These help to reduce the chromatic aberration better than flint glass. Another way is to add more lenses still. So you'll find some telescopes that have 3 or even 4 lenses, all to try to correct that chromatic aberration. A final way is to use one of these, a filter, a fringe killer they call them. A fringe killer will simply block the unfocused light. If you look at the chart here, you'll see that this blocks some of the light in the dark blue to ultraviolet or nearly ultraviolet range. That's what's causing the halos. This is a relatively mild fringe killer in that it kills infrared and ultraviolet. and some of the blue spectrum. A number of these fringe killers will block more than that. They might block the entire blue spectrum. I used to have one that did just that. So you couldn't, if you looked at Pleiades, you couldn't see the little wispy nebulosity because it was blocked. Blue stars, they looked yellow. Oh, one of the disadvantages of blocking the whole blue spectrum is that only leaves you red and green. Red and green added together optically give you yellow. So everything in your view has a yellow cast to it. I bought this particular one because it was only $53. This one was only $35. A lot of the time, a 2-inch fringe killer filter will cost $110 to $225. So the SvBony brand sells a very, very cheap, mild fringe killer. I'm going to show you some photographs I took. I've taken hundreds of photographs with these things using the Celestron short tube 80 and this Sky Optic short tube 90. They're both simple refractors. They both have good glass. No stigmatism or anything, but they do both have chromatic aberration because the light hadn't had time to focus. By the way, you'll find with any short tube, really short tube telescope like f5 or around there, that you're going to have some, and that's why the APOs, apochromatic telescopes, the ones that are trying to block the chromatic aberration, are very seldom f5, or if they are, they're very expensive, and that's 3 or 4 lenses. Most of the ones that try to block the chromatic aberration make them longer, like f6, f7. We've got a couple that are f7. And that helps because being longer and having a higher focal ratio blocks some of it, or allows more light to get focused before you try to mess with it. I've taken a bunch of photographs, and I'm going to put a few in here that I've taken with these 2 scopes. You can see that there's not a lot of chromatic aberration. The filter blocks that. And these are short, wide field, rich field telescopes. If you have any questions, you can go ahead and put them in the comments section below, and I'll try to answer them. And until we meet again, happy trails.